Hi everyone. It's a very good, bright, sunny morning here in Toronto. So welcome back to another session on NASA Open Space, Open Data, and API. How to use its API. So here we have Alex, who is a senior software engineer and tech lead at Metabase. So he's going to drive this representation. Yeah, thank you, Alex. Please, you can start.
Sure. Yeah. Hey, everyone. Let me share my screen real quick. So here it is. Do you see the presentation?
Yeah.
Okay. Yeah. Thank you. So I'd like to talk about open data that is provided by NASA. And the goal of this presentation is to get you started. So it's supposed to be beginner friendly. No prior experience working with NASA APIs is required. And more specifically, I'd like to talk about three things. So the first one is data.nasa.gov portal. Then about Earth data that could be maybe more useful. And then about api.nasa.gov that exposes APIs for some common datasets. Okay, let's start with data.nasa.gov. So the primary purpose of this website is to allow you to search through all NASA datasets. So unlike some other resources, like for instance, Earth data, so this actually allows you to search for everything, but it doesn't host datasets themselves. So in most cases, you just get some basic metadata and the link to the actual resource where you should be able to access this dataset. So yeah, you just need to click this datasets button here in the navigation bar, and then you would see this page. There are several ways how you can search for data. So the primary way is to just enter what you want to find in the search input, and it can be just free form. So the search is semantic, and you can also filter results by tags on the left. So let's try to use it. For instance, let's search for land surface temperature. We got several thousands datasets, but the first one is from Modis, which was expected. So Modis is the name of the sensor that is installed onto NASA satellites, and also it's the name of one of the most popular datasets. So we can click on this entry. We would get some basic information about this dataset. And the most important button here is Explore. And then we can click Go to Resource. And if you follow through links, eventually we will land here. So this is already Earth data, where you can actually download this dataset. And there is also a user guide available about how to work with it. So let's try that. When we click this data access button, it presents us with a number of choices how we can access this data set. For now, let's just click the first one, Earth data search, and I will talk about Earth data in more detail later. You would see something like this, and it obviously depends on what data set you manage to find. So it can be not hosted on Earth data, so it can be just a completely different website. So here you can just download everything, but it would be a lot of data, or you can apply some basic filters. For instance, you can filter based on coordinates or based on dates, so you don't have to download completely everything. That would be hard to process. Okay. So that is quite inefficient to do manually, and there are many different ways how you can access the same data in another way. So for data that is available through Earth data, one of the most popular option is to use Earth Access Library. So that's one of possible ways how you can do that. So you need to log in first, then you can submit a request to download the dataset. and you could apply filters and lines. So here we apply a temporal filter and a bouncing box filter. After that, you could do something with the files. So one possible option is to just list all the data sets that you have. Then you could extract a subdata set, so like a layer, using a raster row. So that's how it can be done. Then there are several common operations that you would need to do. So for instance, with modules dataset specifically, you would probably need to reproject it. So if you want to work with coordinates like latitude and longitude, that's like a very common case, right? So you need to reproject the dataset. So you can do that with different libraries. One of them is Xarray. So you can do that like this. And then also many datasets require some scaling and applying some masks, so just keep that in mind. So usually the user documentation that can be downloaded also at Earth Data states that. So for instance, for modules, we usually need to apply a scale factor. So that's like a very, very short summary about how to use data.nasa.gov. So again, the primary purpose of this website is to allow you to search through all NASA datasets, Earth-related and not Earth-related. Most datasets would be available in this HDF format, and popular Python libraries would be able to work with that. There are many also Python libraries that can allow you to download data via the API, and Earth Access is one of them. For some popular datasets, like modules, for instance, there are also specialized Python libraries that would allow you to work with data like more directly. There are also some unofficial third-party API wrappers, and with them you could just submit API requests. Okay, so the next thing that I'd like to talk about is Earth data. So that seems similar initially to data.nasa.gov, but it's like way more feature rich. So first of all, there is also a data catalog, and it allows you to search for data sets in the same way, but there are many tools to work with data directly. So the most popular ones would be Worldview and also IEEE. So that's how the data catalog looks like. So it looks very similar to what we already saw for data.nasa.gov, right? So there are topics which kind of represent tags. You can also search for datasets in a free form. So it works as semantic search here. But there are also multiple ways how these datasets are grouped. So for instance, you can click on topics and you can select the topic, and it would immediately show you the most popular dataset for that topic and tools that would like allow you to quickly work with this dataset without actually downloading files locally. One of the most popular tools that is available on Earth data is Worldview. So it allows you to visualize geospatial data, and you could upload your data here, or you could select a built-in data set. And it also allows you to combine multiple data sets visually and so on. So it can be very useful to quickly understand what this data is about. Yeah, the next tool that I'd like to just briefly mention is app EARS. So it allows you to do some basic data transformations for datasets that are hosted on Earth data. So for instance, you could extract subsets of datasets based on some more sophisticated filters. You could reproject your data to latitude and longitude, so you don't have to do that locally. You could also visualize your data before downloading to see if it matches your expectations, and it can work with multiple files at the same time, so also very handy. So that is a very quick overview of what is available on Earth data. So again, it's a data catalog for open NASA datasets that are Earth specific. You can download them via the website, or there are multiple APIs available and libraries that work with these APIs. And there are sophisticated tools that allow you to quickly take a look at the data and see if it matches your expectations, and also do some basic pre-processing. So that can be useful. And the next thing that I'd like to talk about in more detail is api.nasa.gov. So first of all, let's talk about the website itself. So this is an API portal that lists APIs to work with datasets. And they are usually more like developer friendly, more beginner friendly than using the dataset directly. And most of the APIs would be REST, but some of them would use some more specific protocols. So the very first thing that you need to do if you want to use this API is to generate your own API key. There is a demo key available, and it's literally spelled as demo_key, but it's heavily rate limited. So the limit is global. There are 30 requests per hour available and 50 requests per day. So you can see that if you all start to use that, then you would be immediately blocked. And all examples that are available on this website use the demo key. So that's why they more often don't work. So if you try to click on the link that is available on this website and nothing works, so the primary reason would be that it happened because of the demo key. So you need to use that with your own API key. Yeah, the key is free, so there is no reason not to generate it. And let me walk you through most common datasets that are available through APIs on this portal. So the first one, which is very basic, is astronomy picture of the day. So you might have seen this website where there is a new image every day, and there is some description about this image written by a professional. So the same data is available through the API. So it's not that basic as it seems, because there is the image and the description that is attached to this image. You can actually use it for something interesting, maybe machine learning or even some Gen AI cases. So that's the base URL. So we can see that it's api.nasa.gov. So it requires the same API key that we could generate on this portal. You can filter by dates and the number of images that you want to get, and you get the URL, the title, and the explanation. So that's how a sample request could look like. So we can see that it's just a basic GET request, very easy. And that's an example of response that is truncated. So the real response has more fields, but the primary fields that we are interested in is the URL, and there are different URLs for different image quality and explanation. Yeah, so like I said, you can actually use it for something interesting with machine learning. The next API that is more useful is about near Earth objects. So near Earth objects means primary asteroids, but also comets. And it allows you to get information about all of them. So it's the ID, its name, orbits, estimated sizes, hazard assessment, and close approach data, and its speed. So that's the data point. We can see that it's the same API portal, so the same API key would be required. There are several primary endpoints. The first one is browse. So you can just get everything and filter by days. When you have this information, you could use the ID returned by the listing point to get more detailed information about some specific asteroid. So you can filter by dates, And for your convenience, you can also get information about all asteroids that would be close to Earth today. The most interesting response fields are ID name, estimated size, whether it's hazardous or not, close approach data, and orbital data. So that's how a sample request could look like. We can see again it's just basic request, and that's an example of the response. It's heavily truncated, so the real response has much more data. But we can see that it's very easy to consume. There are information about asteroids grouped by dates. So it's updated per day. And you can see the speed, the distance to Earth, and so on. There are many ways how it can be used. So including basic cases like visualization, and you can also use that for some prediction models. The next API is called Donkey, and it's an abbreviature for database of notifications, knowledge, and information. So it doesn't mean much. So this is actually about solar and geomagnetic activity that can affect Earth or near Earth space. There are many endpoints, I think maybe about 20 or so on, but probably the most useful ones are about solar flares, coronal mass ejections, geomagnetic storms, and so on. So that's the URL. We can see the same API key is required, and they have a separate endpoint for each piece of information. So for instance, for coronal mass ejections, for solar flares, for energetic particles, and so on. And there is also something more interesting here. They also have a separate endpoint called notifications, which contains some human-readable information that is computed based on all these data sets. So just to give you a quick overview of what's available. So for instance, if you want to get information about solar flares, so you would get some ID, information about time, like when it started, when it ended, the class type of this flare, the location on the sun, and the region number. The API itself is a basic REST, so nothing complicated here. And that's how a response could look like. Again, that's heavily truncated. But just to give you some basic understanding of what's going on. So what can be done with this API? So again, dashboards, monitoring solar activity, also some analysis and alerts. The next API that is probably the most useful one here is EONet, which means Earth Observatory Natural Event Tracker. So this is one of the APIs that is near real time. And it contains information about storms, fires, volcanoes, floods, and other cataclysms. So that's the base URL. So we can see that it's no longer api.nasa.gov, so it's a different portal, and no API key is required. There are only a few endpoints. So the first one is events, which just returns information about all events, which can be active or can be already in the past. There are categories and layers, which exposes images. So for the events endpoint, for instance, you can filter by status, whether it's active or not, and categories. For instance, you might be interested only in wildfires and limit by the number of records or the number of days. That's what you get. So some basic ID, title and description, the category of the event, and some event can be mapped to multiple categories. Also the geometry and the sources. So let's, for instance, get information about active wildfires. So that's how the response could look like. Again, heavily truncated. So we can see that there is some wildfire and BC. That's what we get from the categories field. And there is information about its location, which can be just a point, can be a polygon, and so on. So because this API is near time, it can be actually used for some disaster monitoring applications. And you can also visualize this data, and you can combine this data set with some other popular data sets. So that is useful. The next API that is different to what we already seen is called EPIC, which means Earth Polychromatic Imaging Camera. So there are different images of Earth made by different sensors, different satellites. So this one is for full disk images of Earth, and the satellite is located more like far away from Earth compared to some other satellites. And images can be useful for machine learning cases, especially for things like cloud storms, dust, vegetation assessment, and so on. So the API is available through api.nasa.gov, so the API key would be required. There are two endpoints. The first one is called natural, so you would get images with colors in the same way how a human eye would see them. And the next one is encased, which highlights some regions, for instance, could highlight oceans and so on. So that's how a request could look like. So the same REST style approach. That's what you get. So you basically get some metadata about the image. So mostly the date, some ID, and information about coordinates. So information about the satellite, Earth, Sun, and so on. And that's how the image could look like. So we can see that it's full disk, which is different to many other APIs that return images. So what we can do with that, so we can do some climate-based studies. We can, for instance, track changes in vegetation and so on. The next API that also works differently, so it's not like traditional REST, is Exoplanet API. So it provides an API for datasets about planets outside of the solar system. And it contains a lot of metadata like host stars, discovery methods, orbital parameters, and so on. So that's the base URL. Again, that's not api.nasa.gov, so it's a different portal. Doesn't require the API key, but it uses a different protocol. So you can still get information through regular HTTP requests, but the format of these requests would be different. So this protocol is called Table Access Protocol. There are many datasets available, and probably the most useful ones is PS, which means planetary systems, so like planets, then some post-processed data, PS compress, and also some additional datasets that combine this dataset with others. That's how requests could look like. So here we use a language that is called ADQL, which is similar to SQL, right? So we select top 5 records from one dataset and return information as JSON. And that's how the response could look like. Again, heavily truncated, the real one has a lot of different fields. So that's something that you might want to explore. So how that can be used? Yeah, again, obviously for visualization, but also for machine learning cases. So one thing to note that this dataset is very data heavy, so there are a lot of records. And a few more datasets. So this one is about global imagery browse services. It also exposes images about Earth But unlike the previous one, where we had a full disk image, that would be title-based. So if you want to get a full picture of Earth, you need to combine multiple tiles. And this is much more detailed, much more higher resolution. And one more thing, so when I talk about images, it doesn't mean that it's not like images that you would get if you use your phone camera. So these images are produced by different sensors. So you could get information about fires, for instance, and that's how these fire-specific data sets are also created. So there are different variable layers. So that's how we can get raw data produced by Modist and VIRS. So that's about wildfires. Also about storm activity, weather, aerosols, pollution, and so on. It uses a different protocol called Web App Tile Service, and that is primarily used for visualization purposes. And popular libraries like Leaflet, for instance, they can consume this API, and you can create, for instance, an interactive map where you would display tiles from this image. If you don't want to use that, you can also use direct requests, so they would look like this. We can try to extract an image just to see what the response would look like, and we would get something like this. So that's just one sensor, so one specific tile. Okay, so yeah, you can use that for mostly visualization purposes, but you can also try to do some post-processing of these images. And I want to explore two additional APIs here that will be also somewhat different to what we've seen before. The first one, which is very beginner-friendly, is Insight API, which is about the Insight mission, where data was collected on Mars between these ages, so 2018 to 2022. So this is about weather data from Mars, mostly temperature, wind, and pressure, also some seismic activity, and metadata about sols, which is Martian days. That's the base URL, the same API portal, the same API key, and there are many response fields, but these ones are the most useful. So you can get information about the temperature, the wind speed, the pressure, and the date of this record. So that's how a sample request can look like. You can see that it's just basic REST, and that's an example of the response. So there are sols, which is the Martian day, and they work like indexes. So the very first sol is the date where this lander started his recordings. Then for instance, AT, which is temperature, we can get the average, the mean temperature, and the max temperature for this day. And yeah, we can also get UTCs for like Earth dates. Yeah, what are popular use cases? Yeah, some research. So you can actually try to combine this data, maybe use some models to maybe compare it, make some predictions. Yeah, so it's more maybe analyst friendly than using images. And the next Mars specific API is Mars rover photos. So you can get images raw and with some post-processing from rovers on Mars. And rovers have a lot of cameras, I think that about 10. And this API allow you to get images from specific cameras. So that can be useful. So the same API portal, and there are several key parameters for requests. So the first one is the rover name, which can be curiosity, opportunity, spirit, and perseverance. Then the Martian sol, the Earth date, which can be similar to use, and the name of the camera. So that's how it can look like. So we can get, for instance, photos from Curiosity made on this specific day. And that's how a sample response could look like. I guess that's from some camera where there's an overlap with the rover, right? But there are also some panorama cameras where the view can be maybe more useful, more interesting to users. Yeah, again, you can make some research or analysis of these photos, and you can maybe just use that for visualization purposes. So we've seen different APIs, different ways how to access data, and I want to just to sum it up real quick. So again, the entry point for your data-specific needs is data.nasa.gov, which allows you to search through all NASA datasets that are open to general public, and you can use just free-form text search. If you want to get information about something Earth-specific, I would probably go to earthdata.nasa.gov, which has better navigation and unlike just, and there is also not just search, but also ways to analyze and visualize data real quickly, which can be helpful. And for something maybe beginner friendly, if you want to work with common APIs, I would recommend exploring api.nasa.gov, so it doesn't require you to use any specific Python libraries to process data. So that's a very quick summary that I had. So I hope that it was useful and you can actually get some understanding about what's available. Yeah, thank you so much.
Thank you very much.
Yeah, thank you. Thank you so much, Alex. I think it's a very good introduction to all the open data and how to use it via the API, right? So this is very important because we have 18 challenges. So all the challenges, somehow we need to use this NASA open data because in order to be considered for the global awards, you need to use the NASA open data. So that's where this importance comes in, because there are other open data from other space agencies, but we need to use NASA open data in order to be eligible for the global judging. So if you want to consider it for the global awards, please use this data set. Yeah, that's also we will see you all in coming weekend for the hackathon. Yeah, and Alex will be there for on Sunday as a judge as well. So we will see you, Alex, as well. Thank you so much, Alex. Yeah.
Thank you so much.
Thank you so much. Bye.
Bye.